Hello, let's talk about what is code extraction. Hi, my name is Mishko Hevery. I'm a CTO at Builder.io. We built this thing called the Headless Visual CMS system. I also work on a project called Quick. In the past, I worked on AngularJS and Angular, something called Zone.js, and I try to convince a lot of people that how to write clean testable code. And finally, I had a little bit to do with co-creating Karma. Let's talk about Builder for a second. Builder is a headless visual CMS system. We basically make drag and drop development easy. We also really care about our customers and want to have really fast performance. And so we are focusing on this framework called Quick, which does the best possible time to interactive, PartyTown for making third-party code, and Mitosis, which allows you to write your code once and run on any framework. Specifically for the Builder, we have this cool editor that you can see over here. It allows you to drag and drop a React components or any technology stack you happen to be in. So think like Big's headless visual CMS systems, but for your website. So let's talk about code extraction. So what is a code extraction? So let's think about that for a second. So code extraction is basically code collocation, meaning we want to put code together between server and a client. What do you mean by that? Well, the kind of code that server has to execute is actually different than the kind of code the client executes. On a server, first of all, we have things like NPMs. We can have file system access. We have private keys, which we don't want to share with a user. And on the client side, we really care about size, lazy loading, and of course, the amount of bandwidth we consume. And so there's different constraints in how we package up code and how we write code. But what if, and as a result, we put it in two separate files, but what if you could put these two files together into one? Does that seem like even a good idea? Well, the thing is, the reason you want to do that is because when you write code, you think linearly. You think about, I do step A, then step B, step C, and every time you're asking me to go to a different file, it actually kind of breaks my kind of flow of things. And so it's much easier if I could just explain everything in terms of like how the application should work inside of the same file. The moment you move things into separate files, that means you have to refer to things and you have to go down the line of naming things and giving things names. And that could be troublesome as well. And then because of that, it makes it difficult to navigate code. So somebody new to the project has to find out what all the pieces are. It's tricky for them. And once you separate things out into separate files, now the types don't necessarily flow through the system, and you have to manually put the type system together and make sure that the types on a server and the types on a client are the same. And now that's why we have systems like tRPC, which is the typed RPCs that allows you to write code on both ends and be it correctly typed. And lastly, there's already a trend with existing meta frameworks to do some of this stuff. And I'm going to show you kind of the simple stuff that is happening today, and also the next step of the evolution of code collocation, which I think is what the future holds. So I kind of break down code extraction and code collocation into kind of three things. There's the export extraction, which we're going to talk about first. This is kind of what Next.js does today. There is function extraction, which is kind of the next level up, which is something like Solid.js is doing. And finally, there's closure extraction, which is kind of the advanced mode of doing this. And this is something that Quick.js does. So let's kind of look into export extraction. What is that? So if you look at Next.js, the way Next.js works is that you have the get static props. And basically, this is a piece of code that executes on a server. So here is where you would do your database call. You could talk to the database, you could talk to the file system, anything you want. This can be asynchronous. And so this piece of code right here executes on a server. Whereas this piece of code over here executes, well, kind of in both places, server and client. That's the isomorphic portion of the code base, right? Because when you're doing a server-side pre-rendering, the component executes on the server. But when the component wakes up on a client after the hydration, this piece of code actually runs on the client. And so the way this actually works is that this particular thing is a well-known export. Meaning, if you look for who refers to get static props, if you go to your IDE and say, like, give me references to it, you will find that actually there is no reference. Nobody is referring to this particular thing, and yet the system kind of works. And the reason it works is because at runtime, using reflection, Next.js can look at the file and say, hey, does this file export this special method? And if so, I am going to call it. And whatever this special method returns, I will pass on to this component right here. And this is why we say this is a well-known export. And so the way it works is that we have collocated the code, the server code, and the client code together, and now we run a bundler. And when the bundler runs, you can turn on and off the tree shaker. So if the tree shaker is turned off, the get server props file doesn't get removed, right? Because even though nobody's referring to it and it's not needed, the tree shaker is off. And so that particular piece of code remains in the bundle. On the other hand, when you turn on tree shaker, the system notices like, hey, nobody's actually referring to this piece of code, and therefore it's fair game for me to remove it. And so the kind of code, what the bundles that get shipped to the client contain are much, much smaller because many of these extra server stuff gets removed, whereas what is executed on a server contains both the server bits that are accessed through a well-known export, as well as the isomorphic code that runs both on a server and on a client. Now, the thing to understand is that there's this danger, which is that under no circumstances can a client refer to the server code. Because if that happens, you will break the tree shaker, right? The tree shaker gets broken the moment the client refers to the server core. And so we have to make sure that that does not happen. So let's look at what is not allowed, right? You're not allowed to refer to this. If this piece of code directly refers to that piece of code, all bets are off, and now you have a bundle on the client that contains server-related things. It could be things like private keys, file system access, and other things. Basically, the application stops working because the client cannot execute these pieces of code. And so the thing is, we need to somehow refer to this type, right? We need to basically say that we want to make sure that whatever we return here actually type-wise fits into what is being used at this particular location. And so we need a way to refer to this piece of code without actually referring to it. And so it turns out TypeScript has two modes, right? You can refer to things in a type world or in design time, and you can also refer to things by value. So you can refer it either by type or by value. And because TypeScript runs first, it actually removes all of the type information. So even though you're referring to get static props right here, the TypeScript removes this bit, and so it removes the reference to get static props before the tree shaker runs, and this is why the whole system works. However, if you think about it, this is kind of error prone because nothing is making sure that this piece of code is actually being correctly referred to. I could have put in any at this particular location, the system would work. I could have put in a string and the system would take it. There's nothing in here that actually ensures that the data relationship is there. And the reason why nothing ensures this is because there's no value reference. If I could have an actual call to this function here, then the TypeScript would infer all of the property information, all the type information, and it would make it so that I don't even have to put any types and the right thing would happen. But we can't do that because doing so would break export extraction. So let's move on to the next level up. So this is what we talked about so far is kind of what's happening today in many meta frameworks. This is a new kind of stuff, function extraction that is up and coming. And for example, Solid.js has just integrated it in. And so kind of let's zoom in on that. So the idea behind it is, what if you could mark a particular function, such as over here, as being a server function? And let's mark it using a special function called server $. And by marking it, you can now, you basically are telling the system that this piece of code is on the server, whereas the rest of the code is on the client. So in this particular case, when you have a button, you click on the button, you're actually executing code on the server. Now, that's kind of pretty cool stuff. I think it's pretty amazing. But how exactly would this work? What is required to make this work? Because as of right now, there's a direct reference. This button here, which is running on a client, is referring to the greeter server, and the greeter server presumably has code that you do not want or cannot include on the client. So what is happening here? So in order to do this, you need a piece of code called an optimizer. And we already have code that does code transformation. We call them bundlers, we call them compilers like TypeScript and so on. So now we're introducing a new kind of a tool in a tool chain called an optimizer. Our particular optimizer is actually written in Rust, so it's super fast. It's really efficient in the way it transforms things. And this optimizer does a certain set of transformations to your source code. And so let's talk about these transformations and how these transformations allow you to refer to server-side code from the client. So let's go back to this example, right? So let's again see that we have a button here. And this button has an on-click. And if I click on this button, I would like to call a server function called, which actually just prints out hello. And I would like to pass in world into it, right? So I'm taking a value from the client, calling a function on a server. How could I do this? So let's look at it again. So again, what the optimizer looks for is this marker function. And in this particular case, let's just say we're looking for server $. And what the optimizer does is it takes the body of the function that you see over here and pulls it out into a separate file. So you can see it generates some kind of a random file name with a hash on it and a symbol that is being exported as. So all these things are kind of generated automatically without you having to think about it. And the next thing I want you to notice is this server $, is imported from some particular location. Now, what's actually interesting is that the optimizer doesn't actually care where it comes from. And this is actually kind of the power of it, because you as a developer would like to define the semantics of what does it mean when I call server $. The optimizer's job is really to just move the code around so that you can conditionally import or not import to the code. The optimizer's job is really not to do anything else. And so in this particular case, let's just say we're importing it from some location. So the optimizer isn't looking for a specific import. What the optimizer is just looking for is any function call which has the pattern that it ends in a $, right? So if you can think of it as an annotation. So the server $, or foo $, or blank $, the $, is a form of an annotation which tells the optimizer, I want you to apply this transformation in this particular location. And this is going to become obvious more later on as to why it is that we want to kind of decouple this and not have it tied to a specific function. So the next thing the optimizer does is it transforms the source code as well. Because this piece of code got extracted, what's left behind is a server proxy with a file name and a symbol name. And notice the way the optimizer, what it does, it simply replaces the $, with the word proxy. And the same exact import, which was originally importing server $, now imports server proxy. So it's up to the developer to make sure that the second function is available for the import. Let's look at the server $, function. So by default, server $, function, again, this is something the developer could define, simply just executes the code straight up, makes it async, as you can see over here, so that we can lazy load it or deal with the fact that it's a dynamic import. But for the most part, it doesn't do anything, just passes it through. And the reason for that is because you want to make sure that even if the optimizer doesn't run, for example, in the case of unit tests, you still want to be able to call the function and perform the operations you want. Obviously, you'll only be able to do it on a server, but that's the basically idea, that the server $, by default doesn't really do anything. Now, the server proxy function, on the other hand, is a little more complicated. And what it does is it has a build time switch, right? So during build time, the build system can look at this particular value and says, hey, am I building for a server or am I building for a client? And based on that, it then returns one of two functions here. Now, if we're building for the server, the steps are pretty straightforward. Or what you're doing is we're getting the file and the symbol name, and we're importing the file, getting the symbol out of the export, right? And then we are invoking the function. So we're essentially doing it dynamically, except for the fact that the file is somewhere else. Now, if we are building on the client, we can't dynamically import that file, because if we did that, we would break the system, right? Like the file presumably has things like file system access or something of that sort. So on the client, what we do is we instead generate kind of a proxy, which allows us to call a well-known API service, where we tell it which file we want, which symbol we want to execute in there. And we essentially do a post and we pass into the body the arguments of that function. And we wait for the response and we return the response back to the other side. So now we essentially gotten an RPC for free without really doing a lot of work. So let's go on to the semantic meaning of this particular bit. So what's cool about this is that as a developer, the optimizer, the system that does all these things, doesn't define the meaning of this function. It doesn't even know which particular function you want. Instead, it just says any function that adds a $, will have this particular thing. And it is up to the developer to kind of define what is the meaning here. Maybe I want to have something like lazy $, which will dynamically lazily load the piece of code only when executing and when needed. Maybe I want to run the code in the service worker. Maybe I want to run it on a server execution as we have just shown, or maybe I am already on a server and I wanted to run it even on not another server, somewhere even further down the line. So you can do that as well. Basically, imagination is your limit. You can define your own ideas as to what these things could be and how they could work. We talked about the export extraction, the function extraction. Let's take it up a next level and let's talk about closure extraction. And I think this is a kind of a cool bit out of it. So let's say we have the same exact demo where we have code, there's a button, there's a click on it, and we want to execute this piece of code right here on a server. But notice here, this name is not passed in as an argument. Instead, name is captured inside of the lexical scope because this particular bit here is a closure. So if we just let the optimizer run the way it would normally run, it would generate something like this. And notice this name here is undefined. That's why there's a line through it, right? It would be an error, right? You cannot do this because when you try to run it, the system would say like, hey, I really have no idea what this name thing is. And so we need to somehow restore the lexical scope of the function when it was running. And so the way we can do that is the optimizer can generate a special call in the front called server lexical scope. This particular thing is imported again from the same exact location where the server $sign was imported. And it is up to this piece of this function to kind of restore whatever these variables used to be in order to make them run and work. So it also means that we have to change this piece of code right here, right? So instead of a server proxy simply referring to a particular file and a particular symbol, now we also have to pass in a set of variables that we're capturing. In other words, we're saying, look, these variables are going to be needed later, so I'm going to pass you into the server proxy. It's up to the server proxy to kind of figure out what to do with them. And then on the other side, we're going to call this lexical scope function to kind of restore the variables so that they become available to the code base. Right. So how would this work? So let's say this is being created. So the first thing we need to do is we need to define this function called server lexical scope. This function is pretty straightforward, right? It just returns some global variable called lexical scope, and it's up to us to kind of define what their value is. And so if you look at the server impl, which is the original, this is what the server proxy gets, you'll see that now we're passing in lexical variables into it. And so we have to change the code slightly. We have to obviously dynamically import the file. We have to get the symbol out of the module. We have to save the previous lexical scope. We have to restore the lexical scope that is being passed in. We have to then call the function, right? So when the function gets called, this is the function right here. This is going to get called. This will call this piece of code right here, and this code will return the lexical scope. In other words, it will be able to restore the value that we had over there. And then finally, we have to clean up on finally. And so in this way, we can do that. Now, what I want to convince you is actually this is happening today, right? Like, so Next.js already does export code collocation. Solid.js just added the server $. Remix does export collocation as well. If you look at Svelte or Nuxt, etc., all of these systems are doing some form of export collocation. And Quick, obviously, as I showed you, can do pretty advanced stuff because it can not only export functions, but also closures as well. And so let's take kind of a step into the Quick world and say, like, well, what could you do if you had this kind of a code extraction that could collocate stuff? So here I'm going to show you a very simple piece of code. All it does is it runs some code on a server, as you can see over here. And this is where you would put your database call, etc. On the component, it will fetch the data from the server that was passed in. And notice this bit right here can directly refer to the code over here. There's no need to special type trickery or anything like that to make this work. We then render our button, etc. This button can have a code that runs on the client. Inside of this code, we can maybe create a timestamp or something like that, call a server function that prints something out, and then come back out and return the whole thing. Now, what I want to show you is This is a single piece of code, but the way to look at it is you are guaranteed that these bits of code will always run on a server. And the reason you know that as a developer is because you understand the semantic meaning of this, right? It's not the optimizer that is forcing a specific meaning onto you. Instead, it is the library that you happen to be using, or the framework, or your own things that you happen to be using that give this optimizer the semantic meaning to what it means. And so as a developer, when you develop with a particular library, you kind of know like, hey, this bit's right here, I know will run on a server all the time. And it's kind of cool that you can just put everything in the same file and have all the pieces work together. This piece of code, on the other hand, will run both on a server and client. Sometimes people refer to it as isomorphic execution, right? So on a server during server-side rendering, you know that this particular code will execute, but you also know that this code can execute on the client because it's possible that component it gets re-rendered or something changes, etc. And so both places of execution are valid for this particular piece of code. But you can see that there's island in the middle. This island will not execute on the client. You know that for a fact. And so if you go even further, now you know that the on-click listener only executes on the client, right? It's not possible to do any kind of DOM event interactions on a server. And so you know that this piece of code is for sure going to run on the client. And inside of this piece of code, there's an actual island in there that refers to a piece of code that actually runs on a server. And so I think this is a good developer experience because you can, in a single file, that in a very natural way, express the behavior of the system. You can clearly say, I'm fetching data on the server here, I am handling a click listener on this location, I am updating the UI over here, and so on. And so the whole thing becomes very streamlined and straightforward. And so I think that the idea of code collocation and closure extraction actually brings a new level of developer experience productivity. And it adds to, basically makes it easier for people for developers to just express themselves as to what they want to build. Anyways, I hope you enjoyed this. You can find me more on Twitter at mhevery. And if you want to check out Quick or Builder, you can find us at builder.io or quick.builder.io. Hope you had fun.